So welcome to 11.9, the last regular lesson of this unit. We're really going to be repeating 11.8 a lot here, but what we're going to be doing is multiplying fractions that contain polynomials. So let's remind ourselves of the last lesson, right? So if you're looking to cancel an x minus 7, you better have an x minus 7, and I think this is x minus 7, x plus 1. Those cancel, and you get x plus 1 over 1, or x plus 1. Here, you factor whichever one you find easiest. I'm going to do the top one. It's x plus 3 times x plus 9. Okay, and so it could be 3 or 9, but I got an 8 here. I think I'm going to have to use x plus 9 to do that, and then x minus 1. Does that work? Yeah, it does. So the x plus 9s cancel, and you get x plus 3 over x minus 1. Right? Remembering here that x can't equal 1, because that would make this denominator equal to 0. X can't equal 7 here, because that would make that denominator equal to 0. Right? We're finding expressions that are equal for all values of x usually, but in this case, because a denominator cannot equal 0 ever, then we have some excluded values. Now what we're going to do today is multiplying fractions, right? So if you had 5/7 times 7/9, yeah, you could multiply across and get 35/63, but then you would have to simplify, right? You'd have to simplify, and it would simplify to 5/9. So there's a way better way than doing what I just did, called canceling. You just cancel the 7s like we've been canceling. And so the answer is 5/9. Right? So that's multiplying fractions. So now we have two fractions here. X plus 6 over x plus 5 is a fraction, and we're multiplying, right? We don't have a, whenever you don't see an operation, it's always multiply. And we're multiplying that times x minus 1 over x plus 6. Well, we could multiply across and do it that way, but the fact is you can cancel x plus 6. And so you get x minus 1 over x plus 5. Right? It's really the same as yesterday. So let me show you another example of the one in blue here, right? We can cancel the x plus 5s clearly. Now we have an x plus 1 here. Can we get an x plus 1 out of this? Well, yeah, we can, right? It can be x plus 1 times x plus 3. So then the x plus 1s also cancel. Whoops. Oh, and I see I factored it all here. So here's the factoring where you cancel the x plus 5s, you cancel the x plus 1s, and you get 1 over x plus 3. Okay, so we're going to look for factors to cancel, right? So right off the bat, we can cancel x minus 4. Now, you don't have to rewrite the whole thing anymore. What you can do is I'm looking for an x plus 2. So I write x plus 2 right above this. I cross it out. And then it's x plus 2, I believe, times x plus 3. And then let's just change the color here. So cancel out this x plus 2, cancel out that x plus 2. That x plus 3 is still there, right? Right. When everything is canceled, by the way, you get a 1, right? So it's x plus 3 times 1. It's 1 times 1. And so this is x plus 3. Look at that. That is way simpler than what we started with. So you can, this is called, by the way, it's called rational expressions. We're multiplying rational expressions. That's a fancy name for fractions with polynomials in it, rational expressions. Okay, so I'm looking for an x plus 3. Let's see if I can get one right here. X plus 3, that's x plus 3. I'm crossing that out, x minus 3. So those cancel. I'm looking for an x plus 7 over on this side. It doesn't have to be cross-cancel, by the way. Let's see that. So is there an x plus 7 times an x plus 1 here? Yes. So nothing's left on the top. On the bottom is x minus 3 times x plus 1. That's it. We've simplified that multiplication of fractions. Okay, we can cancel the x minus 3s right off the bat. Now we're looking for an x plus 5 from right there. That is x plus 5 times x plus 5. So I can cancel one of those x plus 5s. I get x plus 5 over 1, which is x plus 5. Right, now this is over 1, right? Just understand, right? Like this is like, say you had 5/6 times 3, right? You would do 5, 6 times 3 over 1, and then you'd cancel like that. Same idea here. So we're going to look for an x plus 9 in this. Let's see, x plus 9 times x plus 4, yes. So then x plus 9's cancel. So on the numerator we have 7, right? We still have that. We still have x plus 4. That's all over 1, but that's just 7 times x plus 4. Okay, again, so we're looking for an x minus 4 out of that. Can we get one? Yeah, x minus 4 times x plus 4. We're getting an x plus 2 out of that. Yes, by removing a 5. And this is usually the toughest thing for people to see, right? 5x plus 10, I can't factor any other way, but I can remove the 5. And then I can cancel this x plus 2. So I have 5 times x plus 4 all over 1, which is 5 times x plus 4. Okay, I'm looking for an x minus 3 over here. Yeah, if I take out a 7, I get a 7 times x minus 3. Over on the other way, I'm looking for an x plus 11. X plus 11 times x minus 2. Yeah, those cancel. You get a 7 on the top, and you have an, that's gone. And you have an x minus 2 on the bottom. All right, now that was multiplying fractions. Now you can't cancel division. You can't cancel adding or subtracting. So we have, what do you do when you divide fractions? You multiply by the reciprocal. You have to flip over that second fraction, right? When you do 1/3 divided by 1/2, you do 1/3 times 2 over 1, which is 2/3. Half of 1. All right, 1/3 divided by 2 is 2/3. Okay, you multiply by the reciprocal of the second expression. Same thing, rules are rules in math. So now the x plus 5's cancel. We're looking for an x minus 6 in this one, which goes with an x minus 1, yes. And you get 1 over x minus 1. So this is x plus 8. The first expression when you're doing this never does anything. And you multiply it by x minus 5 over 1. All right, so we're not going to be able to cancel this x plus 8, at least from here. All right, so we're going to cross that out, and we're going to look for an x minus 5. X minus 5 times x plus 7. Yes, and so this is x plus 8 over x plus 7. Okay, so you leave the first expression the same when you're dividing fractions. Okay, and then we multiply by the reciprocal of x plus 4, which is 1 over x plus 4. So we cancel the x plus 4, hopefully with something over here. And we get x minus 10. Yes, x minus 10. So we get x minus 10 over x minus 2. Yeah, those are, both even, but that doesn't matter because they're part of a group. That's all you can do. Okay, so let's do all of these. So here we're looking for an x plus 7. And that does have one because you can do that. We're looking for an x minus 6 here. And these are the difference of perfect squares, so you can do that. And this is x plus 6 over x minus 7. Here, all right, you're looking, now this is a little harder. 13x minus 2 is 26. I'm looking for x minus 2 there. Can I do that? Yeah, 13 times x minus 2. So these x minus 2's cancel. And let's see if I can get a x plus 7 out of this. Now, there's a common factor here, 5. So let's take that one out first. X squared plus 8x plus 7. And then I could do x plus 7, I need that, times x plus 1. Okay, so those are all gone. X plus 7's cancel. So what do I have left on the numerator? I have this 13. That's still there. And on the bottom, I have 5 times x plus 1. Right? This we're dividing, right? So we leave the first expression the same and we multiply by the reciprocal. Right? So now we can cancel the x minus 4s. Now we're going to see if we can get a 2x plus 1 out of that. 2x plus 1 and times x plus 9. Does that work? Yes, it does. So this is x plus 9 over 1, which is x plus 9. Next one, so you leave the x minus 8 over 7, and then you multiply by the reciprocal of that, 1 over x squared minus 9x plus 8. We're looking for an x minus 8 out of that. Otherwise, that's a very sloppy x. X minus 8 times x minus 1, yes. And so this would be 1 over 7 times x minus 1. All right, so we have negative 10x minus 20 all over x squared minus 6x plus 5, and then we got to multiply by the reciprocal. Okay, now the easiest thing is let's try to find an x plus 2, right? So we're going to see if I can make an x plus 2 out of that. Is negative 10, I take a negative 10 out of there, yes, and I can cancel the x plus 2's. Okay, now this clearly has a 10 in it, so let's take the 10 of that out and get x squared minus 6x. Oh, now this is the first time we've had this. Notice, this trinomial is the same as that trinomial. We can cancel the whole trinomial right now. Now, we could factor them both out and do it one at a time, but those are exactly the same. So, done. So this is gone, that's gone, that's gone. What's left? This negative 10 and that, this is equal to negative 100 over 1, negative 100. No matter what value of x you put in there, other than ones that would make this equal to 0 in the denominator, which like x can't be negative 2, okay, and we could figure out the factors there, x minus 5, x minus 1. So it can't be negative 2, it can't be 5, can't be 1, but for any other values that don't make that denominator 0, that will end up being negative 100, no matter what, except for those 3x's. I wish I could say that. But good luck with the homework.